Good one to all of you. Today, our subject is thermodynamics or engineering thermodynamics. Engineering thermodynamics. Right? Last class, I have discussed about steady flow energy equation. Steady flow energy equation. Right? The equation is Q minus W is equal to H2 minus H1 plus K2 minus K1 plus P2 minus P1. Right? This is steady flow energy equation. Today, I will apply this steady flow energy equation to open systems. Clear? To some engineering thermodynamic systems. So, now we will discuss about application of steady flow energy equation. Application of steady flow energy equation to thermodynamic devices. Thermodynamic devices. Clear? Or open systems or engineering systems. Now first I will discuss about boiler. What is boiler? First I will discuss about boiler. What is boiler? In a boiler, the heat supplied to water generates steam. This steam is supplied to the steam engines or steam turbines. Right? So this is boiler. This water. This is steam in. This heat supplied to the boiler Q. It's heat supplied Q, water supply, steam out. This is steam. Water in, steam out. Clear? So in case of boiler, heat supplied to the boiler. When water enters to the boiler, the water is heated, generates steam, and steam is supplied to the steam turbine, steam engine. Clear? A boiler is a device in which water is heated. Water is heated and generates steam or produces steam. Clear? Then the steam supplies to the steam engines or steam turbines in case of power plants. So in this case, In case of boiler, there is no change in K and P. There is no changes in current energy and potential energy. Clear? Also, there is no work done. There is no work done. That is delta K is 0 or K2 minus K1 is equal to 0, P2 minus P1 is equal to 0, W is equal to 0. Right? According to steady flow energy equation, what is Q minus W is equal to H2 minus H1 plus K2 minus K1 plus P2 minus P1. Clear? This is steady flow energy equation. So in this case, K2 minus K1 0, P2 minus P1 0, W 0. So what is Q is equal to H2 minus H1. That means the heat supplied to the boiler increases the enthalpy of the gas. Clear? Hence, it is clear that the heat supplied to the boiler increases the enthalpy of the gas, steam. The enthalpy of the steam. Clear? This is a boiler. Next, condenser. Number 2. Now 2, condenser. This is a condenser, right? So this is a condenser, this device is a condenser. In this case, steam enters and condensate out. This coolant in, coolant out. So this condenser is used to condensate steam. In case of steam power plants, using water as cooling medium. Whereas in case of refrigeration units, it is used to condense vapor refrigerant by using air as the coolant. Clear? A condenser is a device which is used to condense or condense steam. Clear? In case of steam power plants, in case of steam power plants, steam power plants, it is used to condensate steam by using water, by using cooling water as coolant, as coolant or cooling medium. Clear? So in case steam power plants, the steam is condensate by using coolant, or coolant is cool water. Clear? Or cool water or cold water. Right? Similarly, in case of refrigeration units or refrigeration plants, in case of refrigeration units, it is used to condense vapor refrigerant, vapor refrigerant by using air, by using air as coolant or a cooling medium. Coolant means cooling medium. Clear? In this case, in this case, there is no changes in K and P. Clear? That is K2 minus K1 is equal to 0, P2 minus P1 is equal to 0. Clear? Also there is no work done. Also there is no work done. That is W is equal to 0. Clear? Again heat is rejected due to coolant. Also heat is rejected due to coolant or condensate to condensate. Clear? That is Q becomes minus Q. So put values in static flow energy equation. Right? Putting all the values static flow energy equation. So according to steady flow energy equation, Q minus W is equal to H2 minus H1 plus K2 minus K1 plus P2 minus P1. Right? This is static flow energy equation. Here, this K2 minus K1 0, this P2 minus P1 0, W is 0, and Q becomes negative Q, minus Q. Right? So, minus Q is equal to H2 minus H1. This implies Q is equal to H1 minus H2. Means H1 is more than H2. That means enthalpy decreases. In case of boiler, enthalpy increases. In that case, Q is equal to H2 minus H1. But here, Q is equal to H1 minus H2. So, in case of boiler, the enthalpy of the system increases, whereas in case of condenser, its enthalpy decreases. Right? Next, evaporator. Next, number 3, evaporator. So, the evaporator is a device which is used in refrigeration plants, in which the liquid refrigerant passes, receives heat, and leaves as vapor refrigerant. This is evaporator. In this system, in this device, the liquid refrigerant enters, receives some heat, then leaves as a vapor refrigerant. Right? An evaporator is a device which is used in refrigeration plants or units. Clear? In this system, in this device, the liquid refrigerant passes, the liquid refrigerant passes, receives heat, and leaves as vapor refrigerant. Vapor refrigerant. Clear? Also, in this system, there is no changes in K and P. Clear? Also, in this system, there is no changes in K and P. K and P. That is K2 minus K1 is equal to 0, P2 minus P1 is equal to 0. Right? No change in K and no change in P. That means K2 minus K1 0, P2 minus P1 is equal to 0. Also, The work done is negligible. The work done is negligible. That is W is equal to 0. Right? According to steady flow energy equation, according to steady flow energy equation, Q minus W is equal to H2 minus H1 plus K2 minus K1 plus E2 minus E1. This is 0, this is 0, this is 0. Clear? So what is Q is equal to H2 minus H1. This is for evaporator. Next, nozzle. Number 4, nozzle. This is a nozzle, this inlet, outlet. The process is insulated, so there is no Q. Heat transfer is 0. Neither receives heat nor leaves heat. Also, the nozzle is in horizontal position, so there is no change in potential energy. Also, the work done is negligible. Clear? So, what is a nozzle? The nozzle is a device which increases the velocity and hence the kind of energy of steam. Clear? It's insulated. It is insulated. That is no transfer of heat. The nozzle is insulated. That is, there is no transfer of heat. That is Q is equal to 0. Clear? Hence, the flow of steam through a nozzle is adiabatic. Right? No transfer of heat. So Q is equal to 0. That means the process is adiabatic process. Also, there is no work done. That is Q is equal to 0. Right? Q is equal to 0. That is W is 0. Sorry. That is W is equal to 0. Clear? W 0, Q 0. Now P. This is horizontal position. Suppose this is dead level. Suppose this is dead line. So this is Z1, this is Z2. Clear? So since Z1 is equal to Z2, P1 is equal to P2, so delta P is equal to 0. Since the nozzle is in horizontal position, hence there is no change in potential energy. No change in potential energy. That is P2 minus P1 is equal to 0. Clear? Here Q0, no transfer of heat, no work done, double 0. Nozzle is a horizontal position, so delta P is equal to 0. Right? Now, according to steady flow energy equation, Q minus W is equal to H2 minus H1 plus K2 minus K1 plus E2 minus E1. Clear? This is 0, this is 0, this is 0. So what is K2 minus K1 is equal to? This implies K2 minus K1 is equal to H1 minus H2. Clear? This implies half m into V2 square minus V1 square is equal to m into H1 minus H2. Clear? This implies this is kilojoule. So we'll convert this kilojoule. So divide this by 1000. Clear? This enthalpy is always kilojoule. So this should be kilojoule. So to make this kilojoule, divide 1000. Right? Or, okay, you may do in problem. When solve a problem, you will make the unit same. Clear? Now, V2 square minus V1 square is equal to 2 and H1 minus H2. This implies what is V2 square is equal to V1 square plus 2 and H1 minus H2. Always enthalpy is a kilojoule. So this is half mv square joule. So it is better to do here. It is better to divide this 1000. Clear? This is into 10 to 3. This is 10 to 3. So, what is V2 is equal to? Root over V1 square plus 2002 H1 minus H2. This is expression for velocity at outlet of the nozzle. Since the exit velocity is always more than the inlet velocity. As compared to exit velocity, the inlet velocity is very small. Clear? If the velocity inlet V1 is very small and neglected and is neglected. Then put u1 is equal to 0. Clear? So from this equation, what is v2 is equal to root over v1 square plus 2000 into h1 minus h2. This is 0. What is v2 is equal to root over 2000 into h1 minus h2. This is expression for velocity. Clear? Next, compressor, reciprocating compressor. Number 5, now this is air compressor. Air compressor. What is air compressor? This is device which compresses air, discharges with high pressure a limited quantity. Clear? Air entered to compressor, then compression process down, air compresses, the pressure rises, this compressed air comes to a receiver which receives compressed air, then it supplies as per our requirement. Clear? So the air compressor device is a device which compresses air and discharges with high pressure, with a high pressure and in a small quantity, in a considerable small quantity. Where air enters, compresses, compression means the pressure increases, volume decreases. Clear? So with the high pressure, a small quantity then discharges. In this case, there is no change in K and P. That is K2 minus K1 0, P2 minus P1 is equal to 0. Clear? Also, heat is rejected and gas is compressed. So negative work negative heat. Clear? Also, also the heat is rejected and the gas is compressed. The air is compressed. So Q becomes negative Q, double becomes minus double. Clear? Q becomes minus Q, double becomes minus double. According to according to steady flow energy energy equation, Q minus double is equal to H2 minus H1 plus K2 minus K1 plus E2 minus E1. This is 0, this is 0, double becomes minus double, Q becomes minus Q. Right? So minus Q is equal to minus Q minus half minus double is equal to H2 minus H1. Right? So W is equal to minus Q plus W is equal to H2 minus H1. Or W is equal to Q plus H2 minus H1. Right? This is all about different thermodynamic devices using steady flow energy equation. Now I will do some problems relating to this theory. Clear? Now, before doing problems, I will do what is turbine and what is rotary compressor. Next, I will do problems. Clear? I have already told you boiler, condenser, nozzle. Clear? Air compressor. Now I will do turbine, rotary compressor. Then I will do some problems. Clear? This is turbine. What turbine? In this case, this turbine is insulated, no transfer of heat, Q is 0. This is gas or steam in, gas or steam out, this is what done. It converts the energy of the working substance into work. Clear? A turbine is a device. A turbine is a device which converts the energy of working substance into work. Into work. Clear? The turbine is insulated. The turbine is insulated. That is, no transfer takes place. That is, there is no transfer of heat. That is, Q is equal to 0. Clear? Also, now, according to static flow energy equation, according to static flow energy equation, Q minus W is equal to H2 minus H1 plus K2 minus K1 plus P2 minus P1. Clear? This Q is 0. So, minus W is equal to H2 minus H1 plus K2 minus K1 plus P2 minus P1. Also in cases, the changes in K and P negligible. K and P are negligible. Clear? That is K2 minus K1 is 0, P2 minus P1 is equal to, clear? This is 0, this is 0, right? So, minus W is equal to H2 minus H1. This implies what W is equal to H1 minus H2. Clear? This is turbine. Next, rotary compressor. Number 7. Number 7, rotary compressor. We are done reciprocating. Now this is rotary. Clear? This is rotary compressor. Rotary compressor. This is rotary compressor. So in this compressor, the air is compressed and supplies at a moderate pressure with large quantities. Clear? A rotary compressor device is a device which compresses air and supplies the same. And supplies the same at moderate pressure, moderate pressure and in large quantities, and in large quantities. Also, this is insulated, that is Q is equal to 0. Clear? Q is equal to 0. According to the different energy equation, energy equation, according to different energy equation, Q minus W is equal to H2 minus H1 plus K2 minus K1 plus P2 minus P1. Clear? So Q dash 0, so minus W is equal to H2 minus H1 plus K2 minus K1 plus P2 minus P1. Also, the change in K and P neglected. The changes in K and P is neglected. Change K and P is neglected. And the air is compressed. The air is compressed. That is what becomes negative work. Work becomes a negative. Clear? So put in this equation, double negative, K2 minus K1 0, P2 minus P1 0. So put double negative work and K2 minus K1 0 and P2 minus P1 is equal to 0. Clear? Now, so in this equation, this is 0, this is 0, this becomes minus W. So minus of minus W is equal to H2 minus H1. This implies what W is equal to H2 minus H1. Clear? This completes our theory for steady flow energy equation. Right? Next class, I will do some problems related to this theory. Our completion chapter is first law thermodynamics and application of first law thermodynamics, steady flow energy equation and its application, dependent gas laws. All these are completed. Only problem of this chapter will be done. Then I will start for second law thermodynamics. Then entropy. Then steam. Clear? Please make, like, say so, subscribe all these are videos and play and watch all the videos. Thank you.